Hey guys, it's Miss Johnson and I'm here to bring you our notes for Unit 2 Learning Target 3. Today we are talking about dividing monomials. So last week we talked about simplifying monomials and multiplying monomials together. Today we're going to look at dividing monomials. So going back to those rules of exponents, we talked about when we multiply powers, we add their exponents. We're going to do kind of the opposite here. When we divide our powers, we're going to subtract those exponents. That's going to be kind of our example here. So let's say I have something like x to the 5th power divided by x squared. If I were to expand both of those out, this would look like 5x's multiplied together on the top. So x times x times x times x times x. And then on the bottom, 2x's multiplied together, x times x. When you think about dividing any number by itself, if I had 3 divided by 3, my result here is 1. If I had 10 divided by 10, my result here is 1. If I have negative 200 divided by negative 200, my result is 1. Anytime you divide a number by itself, it's 1. We don't need to keep those ones in there. So a number divided by itself technically cancels out. So if I have x over x, that cancels out. I can do that again with this x over that x, cancels out. There's no more x's on the bottom to be able to cancel with the top, so I have these 3 left, which ends up giving me x to the 3rd. I've canceled the whole denominator. I don't need it anymore. It would be a denominator of 1, but we all know that when you divide by 1, nothing changes. So I'm left with x to the 3rd. The other way that I can think about that is by saying x to the 5th over x squared is the same thing as x to the 5 minus 2. 5 minus 2 is 3, which is x to the 3rd. So you can see that either way that you look at it, you either expand them out like this, which a lot of people like to do that, or you think of the subtraction, you're going to end up with the same answer. Okay? Okay, so let's go ahead and do some examples. So when I look at number 1, I have 15c to the 5th times d to the 3rd in the numerator, divided by negative 3 times c to the 3rd times d squared in the denominator, okay? So now we've been taught all along that numerator and denominator are separate from each other. But when I look at this, there is nothing that I can do exclusively in the numerator, and there's nothing that I can do exclusively in the denominator. So there's nothing else that I have left to do except for going across the fraction bar. So when I go across the fraction bar, now I can think of this in a couple of different ways. One thing, or in a couple of different parts, I guess I should say. One thing that I want to make really clear, you have to treat these coefficients out front as a fraction. Think about pulling those coefficients off by themselves and reducing it as a fraction there. If I reduce that fraction, I end up with, let me just get some brighter colors here. If I reduce that fraction, I can divide both of these things by 3, and I end up with 5 over negative 1. So it's almost as if I'm canceling this 15 and making it 5, and I'm canceling this negative 3 and making it negative 1. So treat those coefficients out front as fractions. That's going to help you get through these questions. The next thing I would look at my like parts. I have c to the 5th on the top and c to the 3rd on the bottom. So if I have 5 c's on top and 3 c's on the bottom, the smaller number of them is going to cancel out. Whatever the smaller number is, sometimes it's on the top, sometimes it's on the bottom, but wherever the smaller number is, those are going to cancel out. And then the question becomes, how many do you have left? Well, if you start with 5 and you cancel out 3, 5 minus 3 gives me 2. So this top here is going to become a c squared. Then the same thing with the d's. I have d to the 3rd over d squared. And again, you can expand those. That's the same thing as d times d times d over d times d. When I expand those out, this cancels, d over d cancels, and this d over d cancels, and check it out, I have 1 left. I can also think of this as 3 minus 2, which is 1. So the 2 on the bottom go away, and the top becomes d to the 1st. So take a look at what we have left for our answer here. My answer is going to become 5c squared times d over -1. Now, this is a perfectly fine way to write your answer. However, you're not going to see it this way on a multiple choice test. When you take 5 divided by -1, that's really just -5. So if this were a multiple choice test, it's almost like I can take this -1 and plop it right up here, because 5 divided by 1 doesn't change the number part. It just makes this part negative. So if I rewrite this, it would be -5c squared times d. That is my simplified expression. All right, let's take a look at number 2. In number 2, I have 21a to the 7th b squared divided by 28a to the 3rd b to the 7th. So again, you have to make sure that you pull this fraction off by itself. So this fraction of 21 divided by 28, okay, think about that independently of the variables. So 21 divided by 28, I have a common factor there of 7. I can divide both of those things by 7, take a 7 out of both of them, and I end up with 3 over 4. So really this is going to become 3 on the top and now 4 on the bottom. So then let's take a look at the variables. So the a's, I have 7 on top and 3 on the bottom. Well, 7 minus 3 leaves me with 4 left over. I have the 7 that are on the top, so that's where my 4 are going to be. All 3 of these in the bottom are going to cancel out, and on the top I'm left with 4. Then I have b squared over b to the 7th. I have 7 minus 2 b's left. I have 7 on the bottom. I have 2 on the top that are going to cancel. But here, my extras are left on the bottom. So it's the 2 on the top that go away, and the bottom becomes b to the 5th, because 7 minus 2 is 5. So if I write out this solution, or this simplified expression, I should say, I have 3 times a to the 4th on the top over 4 times b to the 5th on the bottom. Let's take a look at number 3. In number 3, I have 3x to the 5th y squared divided by x to the 8th y to the 6th and z to the 1st. If you don't remember that every variable that doesn't have an exponent is to the 1st power. So when I look at my coefficients out front, this is a 3 divided by 1. So there's nothing that I can do with that 3. That 3 is just going to remain the same thing that it is right now, because 3 divided by 1 stays a 3. So then let's talk about the variables. The x's, I have 5 on the top and 8 on the bottom. 8 minus 5 gives me 3. So I know I'm going to have 3 left over, because when I'm dividing powers, I want to subtract the exponents. So I know I have 3 left over, but the question is, where are they? My extra x's were in the denominator. Since my extra x's were in the denominator, all 5 of these are going to go away, and in the denominator, I'm going to now have 3 left over. I cancel out 5. If you start with 8 x's and cancel 5 of them, you have 3 left. Let's take a look at the y's. Y's, I have y squared on the top and y to the 6th on the bottom. So again, I have 6 minus 2 y's left over. 6 minus 2 is 4. But where are the extras? The extras are in the denominator. That's where I have more y's. So both of these y's are going to cancel out in the top, and in the bottom, I'm going to be left with y to the 4th. So let's write out our solution here. When I write out my solution, the only thing I have left in the top is the 3. Oh, and I forgot to mention, z has nothing in the top to cancel with, so z is just going to stay how it is. So the only thing I have left in the top is the 3. In the bottom, I have x to the 3rd, y to the 4th, and z to the 1st. That's my simplified expression. All right, let's try number 4. In number 4, I have -3 over 21 is my coefficient, so let's reduce that. If I reduce that, I can divide both of these by 3. Both of those numbers have a common factor of 3, so that gives me a -1 over a 7. So on the top, I have a -1. In the bottom, I have a 7. Then let's look at the a's. I have a to the 4th over a squared. So 4 minus 2 is going to be 2, and my extras are on the top. So this is a squared. That goes away. b to the 7th over b to the 7th. 7 minus 7 is 0. This is, in essence, a number divided by itself. b to the 7th and b to the 7th are the same thing. So b to the 7th and b to the 7th, they cancel out. Because if I have b to the 0 power, that carries no weight. It has that b to the 7th power is equal to 1. So I don't need to worry about that. And then the c's, there's no c's on the top. So my c to the 5th on the bottom is just going to stay the way that it is. So now let's write out our simplified expression. On the top, I have that negative 1 times a squared. On the bottom, I have 7 times c to the 5th. Now, this is a perfectly fine way to write your answer. But this negative 1 right here, oftentimes, they'll just take this negative and plop it out front of the whole fraction. Because really what that means is the whole fraction is negative. So you may see that listed as negative a squared over 7c to the 5th. Either one of those is just fine. If you gave me this on a quiz, that would be just fine. Let's take a look at number 5. Okay, so in number 5, now I have a whole fraction that's being raised to the 2nd power. This power out here is applying to everything inside. Okay, that means it's everything in the numerator and everything in the denominator. Another way you can think about this is kind of how we thought about it in lesson 2. You can take this entire set of parentheses and multiply it by itself 2 times. If I do that, I end up with c squared times d over d to the 5th times another c squared times d over d to the 5th. Okay, so that's one way to take care of that fraction. So you can then go ahead and put those two things together. So c squared times c squared is going to be c to the 4th. D times d is d squared. And then in the denominator, you have d to the 10th. D to the 5th times d to the 5th is going to be d to the 10th. Now I see that this whole set of parentheses that was raised to the 2nd power is written out as one fraction. And I'm going to go ahead and simplify whatever I can. So d to the 2nd over d to the 10th, there's no other c's to simplify, so the c's I have to leave alone. But d to the 2nd over d to the 10th, I have 2 on the top and 10 on the bottom, and 10 minus 2 leaves me with 8. So these are all going to go away, and I'm going to be left with 8 down here on the bottom. So this whole big thing that we started with turned out to simplify down to c to the 4th on the top over d to the 8th on the bottom, and that's our simplified expression. All right, so let's take a look at number 6 here. So in number 6, I have the set of parentheses 3x squared divided by x times y to the 5th power, and the whole set of parentheses is raised to the 3rd power. So the other way that we can think about expressions like this is simplifying inside first. Sometimes it's easiest to simplify the inside of the expression before we raise everything to the 3rd power, or in other words, multiply everything by itself 3 times. When I look inside that set of parentheses, I see that there's an x squared on top and an x on the bottom. I can simplify those two things. This is x to the 1st down here. 2 minus 1 is going to leave me with 1x left over. So this x on the bottom is going to go away, and the x squared on top now becomes x to the 1st. So really, I have 3x divided by y to the 5th. That's what's being raised to the 3rd power. So now I have a simplified expression on the inside, which is going to make my life a little bit easier after I multiply it by itself 3 times. So I need 3 of this whole set of parentheses. I have 3x over y to the 5th times 3x over y to the 5th, and then times 3x over y to the 5th again. Now I can put those 3 parts together. So 3 times 3 times 3, that's 3 times 3 is 9, 9 times 3 is 27. So I have 27 on the top. X to the 1st times x to the 1st times x to the 1st is x to the 3rd. And then y to the 5th times y to the 5th times y to the 5th, that's 5, 10, 15. So y to the 15th on the bottom. The nice thing about simplifying ahead of time, so I took care of everything that I needed to up here, so that when I multiplied them all together, I don't have anything left to simplify at the end. I've already simplified all the things that I need to, so what I get after I do the multiplication is my simplified expression. Versus over here in number 5, when we did the multiplication first, we had to then go back and simplify after. It really doesn't matter. Each method will work, but usually I choose to simplify inside the parentheses first and then multiply by itself after. Okay, let's try a couple more like that. So we have in number 7, we have the parentheses of x to the 3rd times y divided by x to the 5th, and the whole thing is raised to the 4th power. So again, I'm going to simplify on the inside first. I see that there's an x to the 3rd divided by x to the 3rd that I can simplify. There's 3 x's on top and 5 on the bottom. These 3 on top are going to go away. X to the 5th is going to become x squared because 5 minus 3 gives me 2. So what that leaves me with is just a y by itself on the top, and on the bottom I have an x squared, and then the whole thing is raised to the 4th power. That means I need 4 of this entire thing. So that's y over x squared times y over x squared times y over x squared again, and one more time y over x squared. So I had 4 sets of that entire set of parentheses. So now let's put all those like parts together. In the top, I have y times y times y times y. These are all y to the 1st power, so I have 1, 2, 3, 4 of them, y to the 4th. In the bottom, I have x squared times x squared times x squared times x squared. That's 2, 4, 6, 8, x to the 8th power. There is no other simplifying that needs to be done here, so that is my final simplified expression. Let's take a look at number 8. This is our last one for today. So I have 4 times x to the 3rd times y divided by 6x times y squared. There's a lot to be simplified inside. And when there's more simplifying to do within the original set of parentheses, that's when it's really nice to take care of that stuff first. That 4 over 6, I can reduce 4 over 6 to be 2/3. 4 and 6 have a common factor of 2. So I divide by 2, I get 2 on the top, and I get 3 on the bottom. Then the x's, I have 3 x's on top and 1 on the bottom. This 1 is going to go away, and 3 minus 1 is 2. And the y's, I have a y to the 1st on the top and y to the 2nd on the bottom. So 2 minus 1 leaves me with 1 left over. The y on top is going to reduce. The y squared on the bottom is going to become y to the 1st. So my newly simplified expression is I have 2x squared divided by 3y. And that whole thing is being raised to the 2nd power. Okay, because I haven't touched anything with that power outside yet. So raise that all to the 2nd power, which means I need 2 of this whole thing. So that's 2x squared over 3y and 2x squared over 3y. So 2 of that whole set of parentheses. Now put those like parts together. 2 times 2 on the top is going to give me 4. Times 2 gives me 4. X squared times x squared gives me x to the 4th. And then 3 times 3 on the bottom gives me 9. And y to the 1st times y to the 1st gives me y squared. Just do a spot check just in case you may have missed something. When I look at 4 over 9, 4 and 9 don't have any common factors. So I know there's nothing else that I can reduce with that fraction. Then if I look at the variables, I have an x on the top and a y on the bottom, and that's it. So there's nothing else I can reduce with the variables. But it is good to just kind of do a spot check and make sure that you've simplified everything that you can. All right, that takes us to the end of our notes for today. Thanks for listening, and go ahead and work on your practice assignment and let me know if you have any questions. I'll catch you next time.